Hey, what's up, guys? Um, and today I'm going to be going over the next financial literacy tool we're going to be doing here. Um, and so, just to start off, um, in this scenario, I'm going to be starting my first job, and I just got a $10,000 signing bonus. So I wanted to see what the smartest way I could possibly invest that. Um, And my coworker hypothetically says to go all in on Tesla because it's the future, and an advisor says just go buy an S&P 500 fund. It's consistent. And instead of guessing, I'm gonna use the driver framework to build and test my own portfolio using Python. And this is just gonna break it down from define to reflect, and I'm gonna walk you through it um, like you have no financial literacy at all. So first, we're just gonna define the problem over here. Our goal is to grow that $10,000 without taking any reckless risks. Um, in this scenario, I'm comfortable with very moderate volatility, but I don't want my portfolio swinging 60% a year like Tesla. So here are going to be the six assets I'm going to be testing. It's going to be Tesla, Apple, Johnson and Johnson, ExxonMobil, and the Vanguard Bond ETF and the S&P 500 ETF. And these are all going to be over here. So for example, Tesla and Apple are going to move together about 0.65 correlation, while bonds tend to move opposite to stocks, around negative zero point 0.2. And these numbers are really going to capture how diversification actually works. And that stock bond correlations over here, as we know, when investment goes up, government spending goes down, bonds go down, stocks go up, bonds go down. Um, and this is just going to be our correlation matrix. Uh, and these are visualizer helper functions over here. Um, This is part of the code. It's just going to build a correlation matrix so you can basically see how each asset interacts. And when I plot it later, you're going to see the bright colors between tech names. You're going to see Tesla and Apple are very correlated, stock and stock over here. And darker areas where bonds have that negative correlation to those stocks. And so next we're going to get into the represent section of the code here. And so this is just going to build those matrices I described earlier. Um, and that's the code that's going to detail that over here. And you're going to be able to see that um, when I plot it later, it'll be really easy to see. And basically, the contrast is you're going to see the free lunch of diversification. You combine assets that don't move together, the overall risk is going to drop. And then we're going to go to our implement over here. And so here's really where the math comes into it. This block is just going to calculate each portfolio's expected return, volatility, and Sharpe ratio, which is going to be the risk-adjusted performance. And then I'm going to use a Dirichlet distribution to randomly generate 100,000 different weight combinations that all are going to sum up to one, so it'll be representative. And each row is going to be a unique portfolio, which is kind of me just throwing darts at like the allocation board. And I'm also going to build a small function right here called the Tesla bond curve, which is going to move that moves from 100% bond, that moves 100% bonds to 100% Tesla, so we can see what happens to risk and return when we mix just only those two. And obviously that's customizable. And then we're going to go to our validate over here, and we're just going to validate these results visually. So, um, sorry, let me get to here it is right here. So every dot you see on here is just one random portfolio. Um, I marked the S&P 500 star for just for reference. And then this is going to be your minimum variance portfolio, and then the red max is going to be the max Sharpe portfolio. And as you'll notice the S&P is right in the middle, very balanced risk and reward, while the Max Sharp leans really high to leans high towards high return names like Tesla and Apple, but it still uses the bonds to stabilize these. Um, and next, I'm going to show the Tesla bond curve, which is right over here and right over here. And so starting at 100% bonds, the risk is super low, but returns kind of barely beat inflation. Um, but as I add more, returns jump fast, but so does the volatility of it. So the sweet spot is somewhere between 10 and 20%. Sorry, 10 and 20% Tesla where the curve bends upwards. That's kind of where diversification is, doing its job. And then these are going to be our printed portfolio reports. Um, you know, testing whether or not I can beat the S&P 500's return with less risk. This little filter is just kind of be looking for portfolios that have higher returns and lower volatility than the S&P 500. And if any exist, it prints one with the highest Sharpe ratio. And this is all going to be depicted over here. And usually the winner is going to be, a diversified mix, not maybe not 100% Tesla and 100% bonds, something like a blend of growth of stocks and bonds that helps kind of smooth out those bumps. Um, and these are going to be our reflection prompts at the end. We're just going to look back on what I learned. Um, Obviously, diversification. It's kind of like a free lunch. As long as correlation stay below one, the combined portfolio's variance is going to shrink. And even if you add one small bond position, it's going to pull your risk curve down without really killing returns. And the big kind of aha moment I had was that beating the S&P 500 definitely isn't easy. The market is already most of the times very efficient. But just being able to understand risk versus return, you can kind of customize a portfolio that is going to fit your age and comfort level. In this scenario, we can look at the givens that I used, but maybe 80% stocks, 20% bonds, the little Tesla tilt is what I was thinking. But overall balance is just really key.